Professor Eric Tate was trained as a geographer. Work is on a number, using a number of methods to understand particularly the environmental impacts and interconnections to society. And in particular, and what we'll discuss, I think, today is sort of the connection between vulnerability, adaptation, resilience, and flood. So Professor Tate, in addition to being academically incredibly productive, a very highly regarded instructor and mentor, is also engaged with the world in advising a number of agencies and writing reports, including as a member of the Gulf Environment Protection and Stewardship Board of the National Academy of Sciences, Engineering, and Medicine, and also as an author of the National Climate Assessment, while we still did such a thing. And well, with that, I would like to welcome Professor Tate and then hear from him. Thank you.
Thank you, Gabe, for the introduction. So I'm going to talk today about my work at sort of the intersection of floods and society. Maybe I'll start a little bit by telling you how I got here, at least academic-wise. I was, as an undergrad, I was an environmental engineer, and I graduated from Rice University, and I went on to work in environmental consulting. Our main client for 4 years was the U.S. Environmental Protection Agency. So we assessed how hazardous waste sites are for the Superfund program. So this picture of like someone taking soil samples and maybe sending them to the lab, I did this for several years, and then we'd assess that. So I did that for about 4 years. And then I returned to school to get another degree in environmental engineering, this time from the University of Texas. And my advisor there, he was really focused on hydrology, and he was using this newer technology called GIS at the time so that we could map aspects of flooding. So this is in like the mid-90s, late 90s. And after that 2-year stint, I went on to work again in environmental engineering consulting. This time, our sole client pretty much for 5 years was FEMA. And we were standing up a flooding model that they could deploy across the United States called HAZUS. And floodplain administrators could estimate flood risk in their community and then make decisions. But after Hurricane Katrina, I was really focused on, I thought I understood floods. And floods was about understanding the flow of water, the impacts to buildings, impacts to infrastructure. But the story of Katrina was not that, right? It was the impacts to people. And I kind of had a little bit of a crisis moment. Like, what am I doing spending all this time just focusing on one element? But what we really care about is these interactions of flooding and built environment and the human impacts. And this is when I went to get my PhD in geography. And I'm an environmental geographer now. During my dissertation, I studied social vulnerability, and I mapped and modeled this different dimension of vulnerability to hazards. Environmental geographers, we look at interactions between society and environment, and with a particular emphasis on space and place. So we use a lot of spatial methods that I'm going to talk a little bit about today. So some of the basic themes that inform my work are basically the determinants of risk. And so the one on the left is a report from the IPCC, Intergovernmental Panel on Climate Change. And they posited sort of risk is determined by weather and climate events, so wind and rain and flooding, heat, exposure, so who's affected by this, so who lives in the floodplain, what's in the floodplain, and then vulnerability. If you're in the floodplain, how likely are you to be impacted by the hazard? Later, in the later iteration, AR6 that came out a few years ago, they have the same determinants, but say, look, we can reduce risk by reducing the hazards, so maybe through like levees and flood walls. We can reduce exposure by elevating buildings, for example, or buying out structures, properties. We can reduce vulnerability through disaster assistance and insurance, okay? But I think one of the iterations that I think is maybe coming in this piece on the right, the risks are actually focusing on the human dimensions. And this is probably most where I stand, thinking about the human aspects of vulnerability to disasters. So I'm going to use this diagram on the right, where the focus is on risks to people and well-being, and not necessarily structures, buildings and bridges and things like that used to be my focus. So emblematic of this idea is this quote by Terry Cannon. He's a famous political ecologist in the hazard and disasters field. He said, look, you know, we can think about risk, but there is no such thing as like a universal risk. You know, there's no generalized opportunities. Instead, we have unequal access to opportunities and unequal exposure to risk, okay? And as a result of that, really, if we want to understand these systems, he contends that it's actually more important to discern how human beings in their systems place themselves into relation to each other and to the environment than it is to interpret natural systems. Now, this is not the approach that we take in society. You look at, you know, our policies, you look at our research funding, we look at our rules. You know, the vast majority of it's focused on trying to understand the physical processes, how tornadoes work, how floods work, and then thinking about the exposure part. But if actually it's the social systems that are the drivers, this formulation that was the basis for my work in flood risk as an engineer, where we start with the hazard, we look at the exposure, and then we determine the vulnerability as an outcome, Cannon would say, no, this is all wrong. This is all a series of this linear process is on this foundation of pre-existing social vulnerability that leads to these unequal risks and unequal opportunities. So if we want to understand disaster impacts, we need to build, you know, here's an alternative framing that can be used. And we see these impacts. Flood after flood after flood, it's, you know, particular populations that get hit hardest. This is some excerpts from a National Academies report I was on about 6 or 8 years ago, finding about sort of the impacts from flooding disproportionately fall on certain groups, as well as exposure disproportionately reside in flood-prone areas. And so these are some commonalities we see in disaster after disaster. So to sort of model this, social scientists, geographers, in looking at thinking about social vulnerability, have tried to quantify this. Right? We have models of flooding that are quantified. We have models of exposure that are quantified. If you want to get social vulnerability into the conversation, it should also be quantified to play with these other inputs. And so there's these social vulnerability indices. There's two prominent ones. The one on the left is developed at the University of South Carolina, where I went to grad school. This is the social vulnerability index, and so you can compute social vulnerability and map it, so you can see the red areas through like the Central Plains and the Rio Grande Valley through Texas, maybe higher social vulnerability, some blue areas, lower social vulnerability, so you can get this idea of the spatial distribution. The one on the right is the CDC model. You can see some of the variables that go into their model. They're mapping socioeconomic status and household composition and other dimensions using different variables from the census. This has really been a boon over the last 10 years in terms of policy implementation, because you can take this abstract idea of social vulnerability and simplify its complexity into a single number that people can get, right? And you can map it, so you can compare places. You can use the places that are high to maybe say, I want to allocate resources a little bit differently. Now I know where higher social vulnerability is. Or maybe even like use as a screening for deeper investigation. But there's some challenges in this policy application because these models are super overly generalized. And I'll give you some examples. They discard information, and we don't understand using a single number like what's going on under the hood. So these models, the CDC model, the South Carolina model, the HUD has an indicator called low to moderate income. These are really useful for describing places and describing distributions. We don't really have an understanding, at least empirically, a deep understanding of how explanatory, what's the causation, at least in terms of modeling. What we do know is that they don't tend to be focused on particular hazards, and they're certainly not focused on adaptation. So for instance, you get quotes like this from the Centers for Disease Control and Prevention about their model. It's like, well, we created this and we can use this for all sorts of things, right? For emergency response planners and public health officials. And you can use it before disasters, during disasters, and after disasters, right? It's the one tool for everything. But that's not likely. This is not how vulnerability operates. It is differential. So how can we customize social vulnerability indicators for better use in adaptation planning? I'm going to give you 3 examples that have come out of my research, just to give you a flavor of like how geographers and spatial analysis can fit into customizing indicators. So the first one is thinking about this interaction between social vulnerability and flood exposure, okay? So here we're looking at 2 different dimensions. We start with the flooding. And so one of the cool things over the last 10 years, back when I was working on that FEMA project, if you wanted to understand flood risk, you could build these models, but maybe one county at a time. Over the last 10 years, there's sort of the growth of these continental scale flood models, where you can understand, a level of flooding at every 30 meters square in the globe, pretty much, or at least a modeled representation of it. So we use 2 different versions, one measuring fluvial, so in river flooding for the 100-year event, the other looking at pluvial hazard, so heavy rainfall, also in 30-meter cells, for the nation. And we combine these to have an understanding of sort of the depth of flooding everywhere in the lower 48 states. Then we wanted to look at this other dimension, social vulnerability. So we use this South Carolina model, which uses some statistical methodology called principal components analysis. And we were able to develop an indicator of social vulnerability and map it across the nation at the census tract scale. So census tracts, they're smaller than counties, they're smaller than zip codes. So maybe 1 or 1.5, 2 tracts per zip code is sort of like the spatial extent. So you can see really high social vulnerability in the desert Southwest through the Black Belt region of the South. Lower social vulnerability in the green areas. But we didn't want to just focus on just the flood depth. We want to understand like flood exposure. So who's in the floodplain? So we wanted to get an understanding of where it's flooding that are actually people living. So we used land use classification to intersect that with the flooding and built an flood exposure map. So this is showing really high flood exposure in the lower Mississippi River Valley, along the hurricane coast of the Atlantic, and then the Central California Valley, for example. All right, so we have these 2 inputs, right? Social vulnerability and flood exposure. And here we used a method called LISA, which is basically bivariate clustering. So through this methodology, we can break down the geography of the United States into 4 classes, or really 5. Essentially places the degree of its flood exposure, think about each 30-meter cell, surrounded by social vulnerability. So what's the relationship? Where flood exposure is high, and it's also surrounded by high social vulnerability, you get the high clusters, which is red, right? Where you have high flooding hazard or exposure surrounded by low social vulnerability, you get the high-low clusters, right? So I'm just going to focus on those right now. So this is a 100-year flood for the US. We found that a couple things. Think about population density. The high clusters are much lower density. It's more rural areas that are popping up. And you see this a little bit in the map. Where, by contrast, the high-low clusters are more suburban and urban, which you can't really see at the national scale, but you can see once you zoom into a couple cities, there's a high degree of variation within the cities. So now we are able to look at sort of the geographies of this relationship between social vulnerability and flood exposure. Well, this is nice, but what I was focused on in this paper was trying to understand which characteristics of social vulnerability are most important. And so what we did is we took the high clusters, the reds, right? We said, what are the characteristics, these social vulnerability characteristics here? What are they elsewhere? And what's the biggest difference between these two? Which indicators have the biggest difference? So moving into a high cluster, what's changing? The indicator with the biggest difference was mobile homes. 156% increase in percent mobile homes going into a high cluster. This was a surprise. I didn't expect this finding at all. We didn't really see it in the literature. Usually when people think about social vulnerability, the idea that people come up with is poverty. Let's model social vulnerability through income, okay? And income certainly pops up here, but it's not the biggest discriminator, right? It's race and housing variables that are the biggest discriminator. And so we're able to, make conclusions like, look, it's multidimensional. It's not just reducible to this, right? To income. And maybe we should understand what's going on with mobile homes and flooding, which was an interesting finding. But this is good because we can identify indicators, we can see disparities, but it doesn't really get at like solving the problem. It's sort of like diagnosing what you should be looking at. So some findings, the significance of this work. We identified, which indicators that should be priorities. We identified which geographies and how they differ in terms of social vulnerability and exposure. In these high hotspots, it's something like 19 million people. So a lot of people are dealing with both dimensions of this. The methodology is replicable. So yes, we looked at flood exposure. You could also look at wildfire. You could look at different indicators. But I think what I like about it is if you're trying to have adaptation actions that are not only reducing flood exposure, but also addressing social vulnerability or inequity, here's some approaches to find these places and what to focus on. So that's just one example of how to customize social vulnerability indicators, so it's not the one model that's being used in all contexts. The second example is a project that we just finished earlier this year with the state of Texas, of all places. So, all right, we want to customize, right? So we'd like to customize in ways that indicators are flood focused. We'd also like to customize in ways that are amenable for adaptation planning. And so this is what this study is about, okay? So with my colleague, my postdoctoral associate, Daniel, and colleagues at University of Texas, what we wanted to do was create a customized social vulnerability index. This is what the state of Texas wanted. And they can use it in their flood mitigation planning. So they have it's sort of a multi-criteria decision-making process. So they run some flood models, and this is some sort of weight in their decision. And they have some others, I don't know, all the decisions, right? And then social vulnerability is going to be part of that decision-making process. But they needed some quantified metric, and they needed it to be robust, reliable, because this is going into policy that's going to designate where, I think it's like $7 billion in flood adaptation money. And so this has got to be good. So what did we do? In the last study, we quantified, and we used these spatial clustering methods to identify indicators. Here we did something different. We started with a literature review saying, what's going on? What are everybody else finding about indicators and flood exposure? And so we had a list. But then we also interviewed people in the state of Texas. So Texas is divided has these flood planning groups. The map's up on the right, top right. So we interviewed people from these different regions. We interviewed people from nonprofit organizations and got their take on like, what are you seeing on the ground in terms of who's most affected by flooding? And so we have the source from the literature, the source from the interviews that tells us what we should be looking at and what's the relative importance. Is poverty the biggest driver, or is it something else, like mobile homes that we found in the last study? Here, instead of clustering, we applied an approach called global sensitivity analysis. It's a mouthful, but the general idea is when you're building a model, there's all sorts of choices that a modeler has to make on parameters, okay? So when you're building an index, for example, you have to say which indicators do you want to put into this. Another is like, how important are these indicators? So you think about a composite indicator or an index. I'll give you an example of one that all of you are familiar with. And that's like a grade in a high school or college course, okay? We've got all these indicators. You got homeworks and you got quizzes, right? And then we take some average of your homeworks and you have a homeworks grade. and you have a quiz grade, and an exam grade, and a paper grade, right? And then so you have these categories, and then these get somehow combined to create your final course grade. But maybe homeworks aren't as important as exams, so exams get a higher weight, okay? This is the same thing, except in a class, we know what the major determinants are. Homeworks, exams. In social vulnerability, we don't always know what the big determinants are or their level of importance. So that's what we're trying to tease out of this work, okay? So we can build this flood social vulnerability index. Okay, so in each one of these decisions about the weights, I could weight them equally, I can weight them differentially, I could use this indicator set, that indicator set. These are all plausible choices, but they may have an outsized impact on my final ranking. So we should test that to see how robust our model is. That's what global sensitivity analysis does. So here's sort of like a list of all the different decisions we have to make. But the way I think about it is like you're walking down a road and there's a split in the path. You got to choose a direction. Both directions might get you to where you want to go, but you got to make a choice. And so we're going to assess the impacts of making this choice. This is called epistemic uncertainty. And so we can, instead of building the index one time, we're going to build it thousands of times. We're going to make all possible choices, okay? We're going to choose every one of these and then see how uncertain our index is. So we do this in a Monte Carlo analysis. We know, like, for each place, each census tract, it ranges anywhere from, like, I'm second in the ranking to 178th, right? And this one is like, it ranges from 57th to something else, right? But what is driving, like, how big those windows are? That's a sensitivity analysis. And we applied this to understand, which of these decisions that we're making about how we put variables together or what's our input data set, which are the most important ones. And what we found is, like, there's three choices that are really driving all of the uncertainty in our modeling. Our choices on scaling, this is or treatment or weights, these are just inconsequential. These bars on this chart are pretty low. We found, though, however, like, our choice of data set, our denomination, our aggregation choices are really super influential. So now, going forward, don't worry about these last three. Focus all our attention on the first three. We did that in collaboration with the Texas Water Development Board. So at different stages, we went back to them with our findings. We had conversations. They asked questions about, the statistics and these kinds of things. In the end, we created sort of a statistical model, but they came and said, look, I don't like this public transportation variable anymore. Let's get rid of that because it doesn't meet our understanding of stuff, right? Let's get rid of the education one because it was doing some really strange things with the statistics. We want to include mobile homes. I think we're a big push for that. And keep some of these other ones that had some strange statistics. So in this way, building this index is a bit science, it's a bit art, it's customized to what their policy needs are, okay? And then they were able to go forth and present this to their board, okay? Our final index had 18 indicators in 6 different dimensions. And so we have this indicator set, and we have this map, and then they can use this to say the places that have higher social vulnerability, this is going to factor differently in their decision making around, their investments on flood adaptation. Okay, so here's sort of direct insertion of sort of, our understanding of quantifying social vulnerability into policy decision making. So here we're helping push forward sort of a shift from these general purpose indicators, like apply the same thing to every context. Let's make some customized tools that are for specific users for specific purposes. And so here's some methodology to do that. And we got good feedback from I was just waiting for the other shoe to drop this whole time. We're studying social inequity, we're quantifying this in Texas, like over the last few years. And there's not been a peep, not a single issue came up. They had some really, good questions around sort of, the indicators in inequity. But, they seem to be really happy about it. Now they're using this in their decision making. So I think the one point here is, like, if the decision stakes are low, I'm writing a paper, for example, I'm curious about this. Maybe you don't need to run all this, like, sensitivity analysis to have this robust model. But if you're going to insert this into policy and you're going to decide, like, this place gets money and this, you don't, then you better have a really robust model. And this is not just about social vulnerability, it's about all model processes. Okay, so let me give you one more example of customizing social vulnerability for adaptation planning. And so here, what we wanted to understand is, indices are really good. We can map this index. And you say this place in blue is high, this place is low. Over the last 5 or so years, you've started to see, more and more use of social vulnerability indices in planning by FEMA, by Housing and Urban Development, in their planning processes and disaster recovery. The challenge with indicators is that a lot of people that are in emergency management or in the physical sciences, they say, cool, I don't understand this whole social vulnerability thing, it's pretty fuzzy, but you get me a number, so I'm just gonna use the number. My hope over the last 10 years or so was like, once we get the number into these processes, people would start to ask questions about, okay, this place is blue, why is it blue? What is driving social vulnerability there? That's happened to some extent, but not all that much. And so for this project, we wanted to get at like what's driving social vulnerability in these places. So we wanted to build these multi-attribute profiles, all right? So we want to understand the drivers of social vulnerability. We know that indices have this uncertainty imbued in them, right? So just for example, what is the relationship between disability and poverty in generating vulnerability? Does disability work independently of poverty, or do they work in concert? And this matters when you're building an index. Say, for example, I'm going to build an index and I'm going to add all my indicators together. Disability and poverty, I'm treating them as acting independently. But if in fact they're interactive, then your model doesn't follow reality, okay? So we wanted to get at these intersections as well. The other issue with like indices is like it's hard to, they discard all this information, all the stuff that's gone into it, you just left with this number. And so you could go down to this pillar level. Here it's socioeconomic status, demographic structure, special needs. In my grade example, it's exams and quizzes and stuff, right? But these are also aggregations of stuff, right? Many homeworks go into your homework grade. So you still don't know exactly what's driving it because you've discarded information at that level too. So let's try and think of a different model for doing this, one that's not imbued with all this uncertainty. And so the idea, thinking about like social vulnerability theory and concepts, social vulnerability is described as something that is dynamic. It's dynamic over space, it's dynamic over time, and the other part is that it's intersectional. We can think about, these discrete characteristics, ethnicity, class, race, disability, but in reality, it's the intersections of these that matter perhaps even more. We did a study of literature and reports, and we found that when it comes to flood recovery, it's poor households, in the US, minority households and renters that face the largest barriers in recovering from disasters. But what came out super clear in this work was that it's not just these individual discrete characteristics, it is low-income renters that face barriers that are different from low income and is different from renters. They're an entirely different animal. And so we need to model that as such. We need to model in an intersectional way to reflect reality. And what we find is at these intersectional vulnerabilities, it's a multiplier of vulnerability. And they have these unique outcomes. The challenge is like, it started as sort of like a feminist critique, and it's mainly done through qualitative work with small numbers of people. But how can we apply this in sort of a quantitative fashion over large geographies? How do we get at these interactions? So we kind of had a similar start as the cluster paper with social vulnerability and we have flood exposure. This time we moved up the years, so it's more current in time with the social vulnerability model. With the Fathom data, this continental scale mapping, we're able to go from 30-meter cells to 10-meter cells. And instead of like broad land use classes, we were able to get like specific building footprints. So we had a much higher resolution data set, and we modeled this for the 500-year flood. And so this geography of exposure is a little bit different from the last one. You don't see the lower Mississippi River Valley popping out so much. Appalachia is really apparent in this model of exposure. In this case, what we wanted to do was trying to find these combinations of characteristics. So in this case, we use a methodology called hierarchical clustering. So what it does is it takes all of the indicators and builds them into, like, in this case, 6 different classes, these 6 different profiles. So the dendrogram is what this diagram on the right is showing you. What it can tell you is that profile 5 and 6, for example, the orange and the red, these are much more similar to one another than profile 3 or 4. In profile 1 and 2 are very similar to one another. They're closer. But what's in here? Well, the first thing we can do is map it. So this is not a map of social vulnerability. This is a map of combined characteristics of social vulnerability. It's not mapping the degree of social vulnerability. It's mapping what's behind it. What are the population characteristics in these 6 different groups? Okay? And likewise, it's hard to see what's going on in urban areas. The analysis units are super small there. So you can see here we have New York, Houston, LA, and Chicago, and you can see a lot of heterogeneity in those that you can't really see at the national scale. Okay, so social vulnerability in this case is, this paradigm's not a number, it's a set of characteristics. And so what I'm doing is mapping out or expanding sort of this dendrogram here to this diagram here, okay? And so on the left side, you see these variations from 0 for each of these profiles. So some of the values of the variables are higher than the mean, which is 0, and some of them are lower than the mean. And on the bottom, you see all these indicators that went into it, okay? So what we find, well, there's huge differences in terms of racial and ethnic composition. There's a lot of times people think about like, well, racial minority is a driving factor of vulnerability, but yet there is no such thing, like racial minority put together kind of doesn't make sense. And you see this here in profile 2, you have Asian population, profile 3, Native American, profile 5, black population, profile 6, Hispanic population. These are highlighted in green here. They're in different kinds of groups. They're not the same. They shouldn't be treated the same in terms of analysis or policy. Another difference we see is like what other characteristics go along with them. So I'm going to focus here on profiles 2 and 6 here. So profile 2, along with high Asian population, is really high house value. This is a measure of wealth, okay? Really high amounts of renters and kind of high flood exposure. This is a place that has a lot of flooding, a lot of wealth, right? And that's very different than profile 6. It also has a lot of flooding. High Hispanic population, a lot of people with no health insurance, low educational attainment, high linguistic isolation, meaning they're only speaking one language at home. And so you've got 2 places that both have high flood exposure. You want to come in with the same policies for vulnerability reduction in both of these places? They're completely different places. Even though if you're just looking at the physical measure of flood exposure, it tells you they're the same. Okay? And likely your interventions are going to be ineffective because you're ignoring this reality on the ground. This diagram shows on the left how this is about social vulnerability on the left. So each profile on average has a different level of social vulnerability. So profile 1 is the lowest in social vulnerability. Profile 5 looks like it's the highest. Profiles 4 and 6 kind of same levels of social vulnerability, okay? The diagram on the right is showing flood exposure, which is the places that have, the largest percentage of like buildings that are in the floodplain. And here it's like profiles 2, 5, and 6 have really higher levels of exposure and some really, really high levels of exposure. So what can we take away from this? The most susceptible profile, it's intersections of high flood exposure in 1 and 2, sorry, in 5 and 6, these are the most susceptible, but the drivers are different. Like what's going on in profile 5's different population characteristics than in 6. But we can also think about vulnerability as a spectrum. We don't always want to just focus on, who's the most vulnerable. Maybe we can also understand places that are the most advantaged to understand processes of vulnerability and privilege. And so we can look at profiles 1 and 2 here. These are both, higher flood exposure, but, if we're going to just make decisions on investments based on traditional economic analysis, benefit cost analysis, and this is really efficient, right? Tends to privilege places with higher wealth, buildings that are worth more money, central business districts that have a lot of investment tied up into them. We protect these places over these neighborhoods of poor, lower income housing where there's a lot of people, but in aggregate, their buildings aren't worth all that much, okay? So the general point is these profiles use the same information as building a social vulnerability index, but now we have a differentiated understanding so you can customize adaptation strategies. So in profile 6, maybe you do something that's at the intersection of, multilingual education, multilingual forms in post-disaster assistance, combined with lower income. So some significance here, it's a way to understand and maps empirically these intersectional vulnerabilities. We can take the same places that have the same levels in the social vulnerability index and understand how they're fundamentally different. And this allows us to expand our focus not just from the places that are high and we should focus adaptation to also who should we be focusing our adaptation strategies on? Who should we maybe seek out in these communities to be partners? What places that have similar characteristics might be able to learn from one another, even though they're in different parts of the state or different parts of the country, because they're sort of like sister cities, I guess, Again, this methodology is flexible too. We could use different hazards, we could use different indicators to understand, this intersectional aspect of vulnerability. So I'm going to pretty much stop here, giving you 3 examples. The overall takeaways is that this idea of social vulnerability, it is a core risk determinant, but it is not spatially static. It varies across space, and what's driving it and what's important to it also varies across space. And if we take these high-level indicators from the CDC and we just apply them to every situation, it's very likely to mislead policy. And in fact, it could actually be worse, right? We can make these interventions in the name of reducing human suffering and inequity, but if the models are wrong, we're actually investing in the wrong places. So the places that really have the needs, they're overlooked yet again through our analysis. We need to really understand these interactions, not just these individual risk determinants, but the relationships between them, like in this case, exposure and social vulnerability, to be more effective in our disaster risk reduction. And sort of all these different, I've just given you 3, but there's a lot of other sort of spatial analysis methods that can bring forth information that would otherwise be obscured by not using these approaches. And so we can better understand the processes and make better policy. And this is super important these days because this has been an attack at the federal policy level on anything that's trying to reduce environmental inequity. Here's just a bunch of different programs that have been cut just over the last, since January. Some of the arguments around cutting FEMA is it's ineffective, but there's lots of different approaches to show they've cut programs essentially that are focused on the most effective aspects of reducing losses. Pretty much everything having to do with reducing inequity is on the chopping block. And so there may be another policy window years in the future, and in this time we can improve our models so that they're really right-sized, they're policy-specific, and they're ready for use in ways that are actually going to reduce vulnerabilities. And then, of course, because it's a risk determinant, reduce risk. So I'm going to stop there. I'll be happy to take questions. I think Gabe's going to come up. Thank you for your time.
Okay, so I'm going to make my way to the stage, invite Eric to join me on these comfy little couches. And in the meantime, I'm going to welcome questions from the audience. And I would like the first question to be, if possible, from a student or an early career scholar, so that we can break that seal and then get everybody engaged in the conversation. By the way, Eric can wait for a while. He just talked so if you don't pipe up, this is great for him. And do we not have any there we go.
Thank you for that talk. That was really interesting. I'm particularly curious about your finding of how important mobile homes were as indicators in the first project you talked about. And I'm wondering if you have any insight or even speculation about where that comes from, whether it's the physical aspect of mobile homes, whether it's correlations with income and living in rural areas, whether there's other things about citing mobile homes. So just curious if you've delved deeper into that or have any other thoughts.
Yeah, I was super curious about that one. It turns out there's not a whole lot of literature. We have a speaker series in CPRE called the Bradford Seminar, and our speaker a week and a half ago he does work on mobile homes. And what he and others have found is essentially, yes, it's part the structures themselves being lower quality housing, but a lot of it just has to do with how mobile homes and mobile home parks work in terms of who owns the structure, who owns the land. So in mobile home parks, for example, they're often situated in really low-lying area, really cheap land that flood more, okay? The people that live in these structures may or may not own the structure, so they may be renting it. Even if they own it, they don't own the land. So what does this mean when it comes to post-disaster assistance, which is predicated on home ownership? So they get shunted out in these processes. How does it work when it comes to all sorts of decisions in the city council? They're not often treated as like valued residents of the community. And then of course you do have correlations with like more elderly populations, lower income. You have the intersectional characteristics. So in this case, you have the physical, the political, the social, all converging here to lead to places with lots of mobile homes being more vulnerable.
So, and for those of you online, there's a screen here where I can take questions as well. And until we see a hand up, Carl.
I've found myself thinking as I was listening to you about, you have all these indices for vulnerability, and as somebody not in this field, to what extent those indices match up with outcomes following floods. And I guess what I'm saying is have these indices been validated, and to what extent do they work versus not work very well?
Yeah, that's a great question. So basically, for 15 years, this work was being done in academia. People are making another index here, another index there, doing some study. And then the Biden administration came in and they privileging like reducing social inequity. And then overnight, there's this demand for measuring the social dimensions of inequity to put into environmental policy, including COVID policy. And so all of a sudden, these things were being taken right off the shelf and put directly into policy use. And this question of validation is one that's been, in my mind for 15 years, 20 years almost. And so there is this line of research that's, doing these validation studies, but there needs to be a lot more of it. It can be really difficult. So if you want to validate, you need to validate to some outcome. So if you think about if a place is highly socially vulnerable, then what is the outcome you should validate to? Is it that more people die, that more people are displaced, that you need more disaster assistance, that there's more damage, there's more economic loss? And what you find is, you look at different outcomes and you have different levels of validity. And of course, there's so many different ways of building an index in the first place that it's hard to take these findings and say this is universally applicable. So there just needs to be many, many, many more studies, and then have some systematic reviews and meta-analyses that can see what is generalizable and what bubbles up. I think we're in the midst of that process.
So while we wait for a question, so I was standing there thinking there, some of these, right, where I was thinking about the arrow of causality. Mm-hmm. Right, so you might imagine, as you brought up with mobile homes, where there is this, so to what extent are mobile homes themselves the driver of vulnerability, and to what extent do they reflect something deeper that is shared across all the covariates, that, the fact that, for example, the infrastructure for flood management may be different surrounding mobile homes, that the baseline exposure to flooding, right? Because, certain places were settled as a building, permanent buildings were made at a certain point, and these mobile home tracts are put in later. Mm-hmm. Also the financing structure, right? The financing structure for mobile homes and the financing structure for a home set in the ground are different. Are those the underlying processes?
Yeah, this is exactly what I hope we see more of, and not just blindly taking the maps and saying this is high, which also leads to problems like these places are high, these places are vulnerable, these people are vulnerable, these types of people are always vulnerable, right? So it feeds into these stereotypes about race and disability, like all people in these categories are inherently vulnerable. It's the underlying processes, right? Why is the financing different in a way that leads people to be more at risk? Why is sort of the rules of tenure different in ways that lead to risk? Why, does everyone, is their dream to grow up and, live in a mobile home park? Maybe for some, right? But for others, it's because of constraints. They're constrained by income or constrained by other factors that lead them to live in a riskier area. So I think, that's important to try and understand, okay, you see these outcomes, what are the drivers?
We had a question here.
Hi, thanks. I'm wondering what the scale upon which the model should be applied spatially. So I would imagine that the U.S. has cultural shifts, for example. So urban versus rural, north, south, east, west. You showed maps of the entire country, but shouldn't the model be tuned into specific areas? And globally, for example, different cultures might have different parameters that would.
No, you're totally right. Like there's so many differences across geographies, and even if you get down to countries, and then you get to states, and even within cities, like there's differences. What scale should it be done at? It kind of depends on like what the application is, right? So if you're the UN, you're going to want something that has values for each country. If you're FEMA, then maybe you want something for the whole US. If you're Texas Water Development Board, then you want something for Texas. But it's also interesting about scale. It's not just like how large the analysis is in terms of scope. So, it's also analysis scale. Do you analyze at the state level, the county level, the zip code level, the tract level, the block group level? And so we just had another study that came out in the last month that said, essentially, we looked at Hurricane Harvey, and we had household level data, and we said, if we look at it at the household level, these are the drivers of vulnerability. If you look at it at the census tract level, you get different drivers of vulnerability. So like the findings are a bit scale dependent too. So in terms of like what's universal in findings, we need to do a lot more work at like looking at multi-scale analysis.
Great talk, Eric. I really like how you're thinking a lot about how indices get used in the adaptation policy process. One thing I've been thinking about is to what extent indices that are being used either account for or can account for institutional capacity within varying jurisdictions. So if I give $1 million to a certain local jurisdiction, perhaps it's better equipped to do something with that $1 million than a different jurisdiction.
I mean, an index can ingest whatever kinds of indicators you want it to go in there, right? So what's here, behind each of these variables, it's tied to, a lot of case studies, qualitative studies have gone in after disaster and they've looked at places and they said, renters here, this earthquake renters and this hurricane renters, it keeps popping up. But if we're focused on like issues of governance, institutional capacity, then you're going to look at different kinds of measures. So one of these is like, there's a set of indicators called the Sendai Framework indicators, and these are international, right? And so they have a whole subset. They're trying to focus on sort of disaster management capacity. And so they're looking at different measures. But you raise a great question, right? Depending on your use, you need to focus on like what kinds of indicators are going to measure that better than others, and not just use these one-size-fits-all measures. So, good observation.
Great talk, Eric. Thanks so much. I really like the granularity with which you sort of unpack this idea of vulnerability. My question actually picks up on your answer to the previous question. I'm really curious to understand in your engagement with policymakers whether or not they are in a sense equipped or have a framework for which to use this kind of granular information, or is the process through which you have to kind of work with them in order to have this information be actually used? And you referred to the Biden administration, how that opened the door, but I'd love to hear more. And of course, implicitly, I'm thinking about developing country contexts where state capacity is a huge constraint. So just would like to reflect on kind of the user side of this.
Yeah, so I can talk about like two ways that I've seen. One is sort of at the federal level. So what the Biden administration started doing was things like, in places that are highly socially vulnerable, you don't have to have as high of a local cost share. We're going to reduce your local cost share. You might be more eligible for technical assistance. You might get preferred scoring in terms of project selection. Now, how do they get to this? How do they make these choices? Well, one of the conferences I go to every year, FEMA would go until this year. And a couple years ago, they were in some session, and they said they're basically making these recommendations based on their reading of the research. And so they had some policy, some research analysts that were perusing the lit and finding these kinds of findings and then inserting them into policy. So that was happening, and they had some call outs to me and some colleagues that have been doing this work as sort of being instrumental in making these decisions. But I didn't even know about that until years after the fact when they happened to say something in a session I wasn't even in. The work in Texas is a little bit different. From the start, they wanted to build a custom measure. They didn't fully understand anything. They were convinced on this idea that there's this, this social dimension and we should be measuring it, we should do it in a robust fashion. So it was a little bit of like working together and feeling each other out along the way. Like, what are your concerns? What do you understand? How much information do you want? What are your needs? And so some things that they wanted, we didn't see coming. So it was really nice working with one another. And in the end, they got something that they understood, and they can stand up and they could go to their other meetings and represent what was done, even though at the beginning of this, they didn't understand anything about social vulnerability. So
Rob there's a question here in the back, more? Or Hans, you can.
Fascinating talk. And your three left bars in that graph that you have, the tan and black, I'm trying to understand what I'm supposed to take away from them. One of them is called database. It's when I can get another aggregation. What's it all about? What do I take away from that about this whole subject?
Sure. Okay. So in this sensitivity analysis, it's like, okay, your decision on which indicators to use, this is your data set, okay? And then you have another decision on how much to weight each one, right? And so how does this affect how stable your index is can you make all these choices? So the ones in blue are the main effects. This is essentially your weighting decision contributes to this uncertainty on its own, just the weighting, and the indicator set on its own to the uncertainty. But what we also find, and this is why you can't analyze these one at a time, there's interactions. If you choose this indicator set and this weighting scheme, these have these strange interactions in affecting your uncertainty. So you have to do it in this approach where you're doing this thousands of times. So the interaction effects are sort of like, this is the contribution to uncertainty working alongside with all these other decisions to try and untangle this. And so as a result of having this comprehensive analysis, we can screen out some of these decisions on the right because they don't change the outcome, and we put more attention on the ones on the left. These become the focus of our meetings. This is where we dive deeper into the lit. This is where we more deeply consider our choices. So it's like helping the process along so that you have something that's really robust.
So
Does
we had there we go.
Hi, thank you. This is a really interesting talk. I guess I'm curious as to, most of the social vulnerability data, I assume, comes from like a census or like the ACS survey. But when you're building an indicator, how do you work in the people who don't respond to that, who might be the most vulnerable? And especially, the vulnerability is not homogeneous in time. Mm-hmm. And as the next few years unfold, I think you're going to lose perhaps a lot of that information among some groups who no longer want to respond to a census.
No, that's a great question. And in fact, this is the focus of our current work. We just sent out 2 papers. We got another one that's going to go out in a few weeks. And this idea of measurement uncertainty. And so what we know is we can look at these estimates from the Census Bureau. There are 432 households with elderly population in this census unit, right? But the census also publishes uncertainty measures with this. So you can say well, there's 432 elderly plus or minus 50. Or there's 432 elderly plus or minus 500. What does that even mean, right? And so in addition to the estimate, we also have this uncertainty, and we can measure the effect of that measurement uncertainty alongside your choice of data set and your aggregation method. So this becomes another parameter in our analysis. But we had to have some sort of technological breakthrough to be able to understand the effect of a measurement uncertainty once you start adding all of these different indicators that have different measurement uncertainty. So we've got that now, and we're coming out with some work that kind of shows the impact of that. It's a great question, though. Really pertinent.
All right. So I've been getting feedback from the control room. And so before we thank Eric again, what I'd like to remind you is on Wednesday, October 29th at 4:30 in the p.m., Senator Bill Frist, class of 74, a physician and a former UNS Senate Majority Leader, and currently the board chair of the Nature Conservancy, will give a talk on the intersection of planetary and human health, a doctor's call to rethink health in the age of climate change. This would be a very interesting talk. And then on Tuesday, November the 4th at 12 and 15 p.m., we will have Professor Laura Resplandy from the Department of Geosciences and HMEI giving our next faculty seminar. So with that information in your pockets, and you can find it on our website, please join me in thanking Professor Eric Tate again for a great presentation.